Hello friends, this is Chandrapal Chauhan and today we start with a topic called as the Chomsky Hierarchy, and this Chomsky Hierarchy topic belongs to the subject called as the theory of computation. Right? As we know that this is Chomsky Hierarchy, this particular topic will give you the brief idea or the complete framework of this subject called as the theory of computation. So what this Chomsky Hierarchy is? We come to know that this Chomsky Hierarchy is a man who has derived the language called as a formal language, and he has given this idea in 1956. Who is not this Chomsky? The full name of this Chomsky is Abraham Noam Chomsky. He is a scientist from USA, and he is a multidimensional personality. He is known as a father of modern linguistics. He is a philosopher. He is a psychologist. He is a social critic, political activist, and he is currently working as a cognitive scientist. And he is associated with many universities like MIT, University of Arizona, and he is still alive. He is 90 years old, and he is giving the better contribution in those different areas, right? So we learn what is this Chomsky hierarchy is, and as we know that the Chomsky has given the idea of formal language. So every language generates from the grammar, right? As we are dealing with the English language. English language is also should be syntactically correct, and it follows the rules of the grammar, right? So every language should follow the rules of the grammar, so as this formal language is, and this formal language is understood by the computers, right? And we are having a natural language is understood by the human being. So what this formal language is, and definitely this formal language is also have certain set of grammars, and for this particular grammar we are having this formal language, right? So for what is the grammar for this formal language, right? And what the grammar exactly is, right? So when we say the grammar mathematical definition of the grammar says that it consists of 4 tuples. So when I say grammar consists of these 4 tuples called as a V, T, P and S. And what this 4 tuples is, right? What is V, what is T, what is P and what is S? We'll just briefly discuss about this 4 tuples first. What is this V? V says that it is a set of variables. T says that it is a set of terminal symbols. This P is what? My P is my production rules. And S is my start symbol. So what this V, T, P and S are, right? What is variable? What is terminal symbols in the language, right? Generally, whatever the formal language we do have, this formal language consists of strings, right? And the string is nothing but the set of terminal symbols. And generally the terminal symbols are, all those symbols are denoted with the small letters, right? And the set of variables is generally denoted in the capital letters, right? For the sake of simplicity, we'll take one simple grammar. This, suppose I'm having one grammar which produces S A, and A produces AA, say BA, and say it produces epsilon. So what it is, right? It is a simple grammar. If I start deriving any string from this given grammar, so I'm getting a different languages. So I'm getting a set of string. Suppose this is my first grammar. S produces what? Small a and capital A. If I replace this capital A with this epsilon, the smallest string I am going to get is this A, and A is the valid string for this particular grammar. Suppose if I'll derive some set of strings from this grammar. So what strings I am going to get here? So you listen here. S produces what? Small a and A. And if I replace this A with this rule called as A produces A and this capital A, so what I am going to get? S produces what? A. And if I replace this A with this rule, what is that? What it says that AA, right? And this A produces capital A, and if this A is replaced by this epsilon, so I am going to get this AA epsilon. Epsilon is what? Epsilon is null string, right? We are not reading any string. So here I am going to get the valid string called as a 2a. here this is again a valid string, and this can be a member of this language. That language can be generated from this given grammar. So here I am going to, if I see this set of rules, what are the various set of language or the strings can be generated from this given grammar, I can say that this is my start symbol here, which says that the first letter is A, followed by this capital A. What it says that if this A is there, if I replace this A with any of these rules, I'll come to know that it will accept any string which starts with small a. This end can be have any number of A followed by this small a, or any number of B followed by this small a. But the thing is that it should starts with small a only, right? It can have, again, if I write it down like this, AB, it is also a valid string for this particular grammar. If I say that 3A, this is again a valid string, but we'll come to know that all those strings that I am going to get from this language set, every string starts with small a. So this is the grammar that can be, this is the grammar. From this grammar I have generated few set of strings, and all are valid string, and this is called as a language, and this is the formal language for this given grammar. So here for this particular grammar, for this, if I want to show it, what are my terminal symbols, what are my variables here, and what are my production rules, and what are my start symbols. So I'll come to know that I'll say, okay, this set of variables, I have already told you all those variables, the symbols that are denoted in the caps, that they are my variables. Here I'll come to know, okay, this capital S and this capital A, those are my variables, right? And set of terminal symbols. What are my terminal symbols? Terminal symbols are denoted in small letters here. I can say that this small a, this B, and this epsilon, these are what? These are my terminal symbols. What are my production rules? So whatever this two things I have written over here, these are what? These are my production rules. And from the base of those rules only, I am able to generate certain strings, right? So this is what? These are my production rules. And what is my start symbol? Start symbol is S, because I need to start from somewhere. I need to start deriving the string from some variables. So one of the variable has to act as a start symbol. So for this grammar, I can say that S is my start symbol, and I need to mention here in every grammar from which non-terminal symbol or from which variable I am going to derive my string, right? So this is the grammar, right? And I have just briefly discussed you about the four tuples of this grammar called as V, T, P, and S. Right. So here from this set of grammars, we'll just discuss what is Chomsky hierarchy, what is my formal language, and how the Chomsky has divided the grammar into four different types. And those four different types are called as type 0, type 1, type 2, and type 3. So as we know, the Chomsky has divided the grammar into four different types: type 0, type 1, type 2, and type 3. And we'll come to know that from this diagram. This is a Venn diagram, right? And you'll come to know that type 0 is a superset of all those types, right? So what is type 0 grammar, and why it is the most powerful grammar? So we'll see here the type 0 grammar. The name of this type 0 grammar, it is known by three different names, right? What it says that you can have type 0 grammar is also called as a recursive enumerable grammar, or you can say that it's an unrestricted grammar. This is the most popular name called as the unrestricted grammar. It is also called as a phase structured grammar, right? These are the three different names. So as we say that it is a grammar, definitely every grammar generates a language. So this grammar is also generates a language, and this type 0 grammar, or you can say that this unrestricted grammar, generates a language called as a recursive enumerable language, right? As it generates a language, we must know that if whatever the language is generated by this grammar, it should be accepted by some abstract machine, and we are having a Turing machine for that. And we come to know that if the language, the recursive enumerable language, is accepted by this Turing machine, so we can say that the Turing machine is the most powerful machine over here, because type 0, this Turing machine, it is used to accept the language generated by this type 0 grammar. And as from this Venn diagram, we come to know that type 0 is the most powerful grammar here. So here the type Turing machine is there to accept the language generated by recursive enumerable language. So how can we say that this type 0 grammar is most powerful language? right? And he has divided this grammar into 4 different types based on only the production rules. By viewing the production rules, by seeing the production rules of any grammar, we'll come to know that this grammar belongs to which type, whether it belongs to type 0, type 1, type 2 or type 3. That means what he has done, he has put the restriction on the production rules, right? And he has put the restriction on the production rules, and what kind of restriction he has put over there? Right, here for type 0 grammar, as the name suggests, unrestricted grammar, there is no restriction on the grammar. If there is very simple grammar, if you are not putting any restriction on the grammar, that means what? The language generated from the given grammar is more complex. Right, so that language is complex, and we are having a Turing machine to accept the language which is generated by this grammar. That is why we can say that the Turing machine is the most powerful machine. So what is the production rule for type 0, right, for unrestricted grammar? So for this, the production rule for this type 0, it says that every production rule is having a left hand side and the right hand side, right? And the left hand side, it says that it is denoted by this arrow. This arrow, you can say that arrow, we can read it as that this derived, alpha derives beta, right? So here, what is alpha and what is beta, right? It is having the two different the sides of the grammar. Production rules. So alpha, what is my alpha? Alpha says that alpha belongs to, you'll come to know that V union T star closure, and one V is there. This V stands for variable, as we have seen in the grammar. T stands for terminal symbols, and here the star closure. Star closure means what? 0 or more occurrence, right? 0 to infinity, 0 or more occurrence of variable or a terminal symbols, which can be just leading by this one variable. Thus, but it is said that alpha should consist of one V, right? One V is what? One variable has to be there on the left hand side of the production rules, followed and leading by any number of variable and not terminal symbols can be present on the left hand side of the production rules. This denotes my alpha. So what is beta? On beta there is no restriction. On this, in this beta belongs to what? V union T star closure. That means what? Any occurrence of variable or terminal symbols can be present on the right hand side of the production rules. So this is the production rules for unrestricted grammar. He has not put any restriction on the production rules. That is what is called as unrestricted grammar. The only restriction is this one variable, at least one variable or at least one non-terminal symbol has to be present on the left hand side of the production rule. So for example, if I take one example, so what it says that if I say A, B, which produces A, B, A, that is the valid say production rules, and that belongs to what? Type 0. I can write down anything, but only thing is that at least one non-terminal symbol has to be present on the left hand side of the production rules. I can have like this also A, B, A, capital this small b, that is also a type of what? That is a type of my unrestricted grammar. I can have like this also A capital B and small a. This is also valid production rules for this type 0. Or I can write it down like this, epsilon. This is also valid because what it says that it consists of, whenever you see the left hand side of this production rule, I am having at least one non-terminal symbol that satisfies the property of alpha, and on the left hand side of the production rules, on the right hand side of the production rules, you will come to know that this beta consists of any number, right? It can have a 0. Here it says that epsilon is what? 0 occurrence of terminal or non-terminal symbol is there on the right hand side of the production rules. Here it is 1 occurrence of terminal symbol is there, that satisfies the property of beta. Here any occurrence of terminal and non-terminal symbols are present, so it satisfies the property of beta. So all those 4 types are what? Are a type of unrestricted grammar. You can write it down any grammar which are present or which present of at least one non-terminal symbol are present on the left hand side of the production rules. All those grammars belongs to unrestricted grammar. Friends, we have seen type 0 grammar, right? And type 0 grammar, we have seen that type 0 grammar is called as unrestricted grammar, and this unrestricted grammar generates a language called as recursive enumerable language, and we are having Turing machine to recognize the language generated by this unrestricted grammar. So type 1 grammar. So what is my type 1 grammar? Type 1 grammar is what? Type 1 grammar is called as a context sensitive grammar. It is also called as a length increasing grammar or non-contracting grammar. So as every other grammars, this grammar is also generates a language, but this language is called as a context sensitive language. And we are having a Turing machine to recognize the type 0 or the regular recursive enumerable language. So we are having a linear bounded automata to recognize this context sensitive language. So what is the rule or production rule for this type 1 grammar or context sensitive grammar? So again, it has two parts, left hand side and the right hand side. We are having alpha produces beta, but what is alpha here? Alpha will remain same जैसा मेरा type 0 grammar में था, same alpha I am having here. Alpha produces what? V union T stars, 1 V followed by V union T star closure, right? That means what? At least one variable has to be there on the left hand side of my production rules. उसके पहले कितने भी वेरिएबल और टर्मिनल सिंबल्स हो सकते हैं, उसके बाद भी कितने भी वेरिएबल और नॉन टर्मिनल सिंबल्स मेरे हो सकते हैं. बट व्हाट इट सेज दैट व्हाट इज माय बीटा, right? Here it is changing, right? In my type 0 what was the restriction? There was no restriction at all, right? Beta can be anything, any number of terminal or non-terminal symbols. Variable and non-terminal symbols both are same, right? So here any number of variable and non-terminal symbols were allowed in type 0 grammar, but here in this grammar, as it is a type 1 grammar or it is context sensitive grammar, you come to know that beta mein there is one restriction. What it says that V union T plus closure is there, right? This closure is important. What is this plus closure? Plus closure says that beta consists of at least one terminal or non-terminal symbols, right? It cannot be a star closure. Beta cannot be empty here. And one more, the third property of the production rules of type 1 grammar says that length of alpha. Length of alpha should be less than or equal to length of beta. That means what? The number of symbols which are present on the left hand side of my production rule should be less than or equal to the number of symbols are present on the right hand side of my production rule. So we'll just give some example based on that, whether the given production rules belongs to this grammar or not. Here I'll say that this is what? This is small a, capital A, small b produces what? A and B, that will remain as it is, but this capital is replaced by this small a, right? And we'll come to know that whether it is type 1 grammar or not. Can I say that it is a valid production rules of type 1 grammar? Yes, we'll check it out, all those three properties. What is my alpha? Alpha says that at least one non-terminal symbol has to be present on the left hand side of the production rule. Yes, A is there. A is my variable, one variable is present, that means what? It follows the property of alpha. What about beta? Beta says that at least one terminal or non-terminal symbol has to be present on the right hand side of the production rule. Here 3 terminal symbols are present on the right hand side of my production rules, so that satisfies the property of beta. What about the third property? Third property says that the length of alpha should be less than or equal to length of beta. How many number of symbols are present on the left hand side of my production rules? 3. And how many number of symbols are present on the right hand side of my production rules? Are 3. That means what? Here the length of alpha is 3 and length of beta is 3. So it satisfies the third property of my production rules. I can say that this is my valid production of context sensitive grammar. What about this one, right? It produces what? C A D, which produces C B D. That means what? Here this capital A is replaced what? Capital B. Here the same capital A was replaced by small a, but here the same capital A is replaced by small b. What does it mean? How the computers will come to know that whenever, or the parser comes to know that whenever A is encountered, whether this A is replaced by the small a or whether this C is replaced by small b. What it says that it will work in context, right? What was the left at that time when this A was replaced by small a? उस टाइम पे A का लेफ्ट कॉन्टेक्स्ट क्या था? A का लेफ्ट कॉन्टेक्स्ट क्या था? स्मॉल a, और A का राइट कॉन्टेक्स्ट क्या था? स्मॉल b, राइट? जब A का लेफ्ट कॉन्टेक्स्ट स्मॉल a होगा और A का राइट कॉन्टेक्स्ट स्मॉल b होगा, एट दैट टाइम दिस कैपिटल A शुड बी रिप्लेस्ड बाय स्मॉल a. right? Here again, here this is what A का left context मेरा C है और A का right context मेरा D है. In this terminology, if any A is encountered, then this A will be replaced by small b. That is why it is called as context sensitive grammar. एक ही ये है, एक ही वेरिएबल है, एक ही वेरिएबल मेरा अलग अलग टर्मिनल सिंबल से रिप्लेस हो रहा है. Right, this is what, this is my context sensitive grammar. Here we'll come to know that whether this is the valid production rules of context sensitive grammar or not. What it says that A, capital A, B produces small a, right? Here alpha, this is my alpha. It consists of one A, capital A, this is variable that satisfy this property. Beta, yes, one variable, one terminal symbol is present on the right hand side of the production rule. It satisfies my second property. But what about this third property? What it says that length of alpha should be less than or equal to length of beta. That means what? Length of alpha कितना है मेरा 3. But what is my length of beta? Length of beta है मेरा 1. So this is violating this third property क्योंकि मेरा beta का length क्या चाहिए? Beta का length should be greater than or equal to length of alpha. So even though this particular grammar was valid in type 0, but this is invalid here in type 1. So same here, I cannot use this grammar because the length of alpha is what? Length of alpha is 4 and length of beta is 0. At the same time, it violates this second and third property, right? Beta, इसमें क्या था? Beta is what? Beta is empty, but it says that कम से कम at least one variable or non-terminal symbol has to be present on the right hand side of the production rule. So this is invalid production rules of type 1 grammar. As we have studied type 1 grammar, and type 1 grammar is what? Type 1 grammar was our context sensitive grammar, and context sensitive grammar generates a language called as context sensitive language, and this context sensitive language is accepted by one abstract machine called as linear bounded automata. Right, that we have seen, right? Now this is what type 2 grammar. What is my type 2 grammar? Type 2 grammar is called as a context-free grammar. And why it is called as a context-free grammar? And how this context-free grammar are different from or context-sensitive grammar? We have seen the context-sensitive grammar. Context-sensitive grammar, we have seen that this A and B, suppose, and this is if it is replaced by this A, right? If this A is having a left context A and if it is having a right context B, then this capital A are replaced by, or this whole grammar is replaced by this small a. But as it is a context free grammar, that means what? It does not have any left context, it does not have any right context. That means what? It does not have any left context, and if it does not have any right context, then it produces something, then I can say that it is A. That means what? This A का कोई भी left context नहीं है, कोई भी right context नहीं है. That means what? Epsilon है, nothing is there. That is why it is called as context free grammar. From this example itself, we'll come to know that मेरा जो लेफ्ट हैंड साइड ऑफ द प्रोडक्शन रूल है वो कैसा रहेगा. लेफ्ट हैंड साइड ऑफ द प्रोडक्शन रूल में there should not be any context, it should be free from the context, and that means what? It contains only one non-terminal symbols on my left hand side of the production rule. So here you come to know that it's a context free grammar, and this grammar generates a language called as a context free language, and this language accepted by one abstract machine or one mathematical model called as a push down automata. So what is the production rule for this context free grammar? What is the production rule? What the production rule will be: A produces beta. What is A? A says that A belongs to variable. That means what? On the left hand side of the production rule, only one variable has to be present, and exactly one variable has to be present on the left hand side of my production rules. And what about this beta? Beta will remain same. जैसा मेरा context this sensitive context sensitive या फिर this unrestricted grammar में था, same sort of example is there for beta, but only thing is that context sensitive में at least one terminal or non-terminal symbol has to be present in beta, but here it says that any number of terminal or non-terminal symbol can be present on the right hand side of the production rules in this context free language. For example, if I write it down like this: A produces A, B, A. This is what? This is my valid production rules for context free grammar. Q, it says that this is my alpha. What is alpha? What is the left hand side of the production rule? Left hand side of the production rule says that only one variable or exactly one variable has to be there. So one variable is present on the left hand side of the production rules. And what about the right hand side of the production rule? Right hand side of the production rule says that any number of terminal or non-terminal symbols can be present here on the right hand side of the production rules. So this is the only restriction here in the context-free grammar. So I can say that this is my valid production rules. So here, if I write it down like this, A produces epsilon, then I can say that this is my valid production rules. Why? Because again, left hand side is same. Left hand side mein exactly one non-terminal is there. But what about the right hand side? Right hand side says that null symbols are there, no symbols are present here. A produces epsilon. That means what? Beta is what? Beta is the zero or more occurrence of variable or terminal symbols. Here, zero number of terminal and variable, nothing is present on the right hand side of the production rules. That means what? This is again a valid production for context-free grammar. But this production rule was invalid in the context sensitive because my beta is empty here. वहाँ पे beta मेरा empty नहीं चाहिए था. Beta consists of at least one terminal or non-terminal symbols that has to be present on the right hand side of the production rules in where? In context sensitive grammar. But in the context-free grammar, ये चलेगा. This is my valid grammar here. So my type 2 grammar that we have seen, type 2 grammar is what? Type 2 grammar was my context-free grammar, and context-free grammar generates a language called as a context-free language, and the language accepted by one automata called as push-down automata, PDA. Right. Now we see type 3 grammar. What is my type 3 grammar? Type 3 grammar is what? Type 3 grammar is a regular grammar. This regular grammar generates a language called as regular language, and the language generated by this regular grammar is accepted by one mathematical model is called as a finite automata. So on what basis we can say that the given production rules belongs to regular grammar? We can say that there are certain restrictions. Chomsky has put certain restriction on the production rules. As we know, the production rules are having two parts, left hand side and the right hand side. So what it says that the production rules of my regular grammar, it says that on the left hand side of my production rules, the non-terminal symbol has to be present, but it is exactly one non-terminal symbol has to be there on the left hand side of my production rules. And what about the right hand side of the production rules? What it says that at most one non-terminal symbol can be present on the right hand side of my production rules. What does it mean? इसका मतलब ये होता है कि left hand side में अगर non-terminal symbol present है तो कितना रहना चाहिए? That has to be there, but exactly one only. Right, and right hand side में if the non-terminal symbols are present तो at most रहेगा तो ज़्यादा से ज़्यादा एक, right? At most one non-terminal symbols can be present on the right hand side of the production rules. So if it satisfies this rule, then I can say that this particular production rules belongs to regular grammar. For example, here I can say that if I say capital B produces what? Small a. Right, what does it mean? Left hand side में exactly one non-terminal symbol present है. That means what? It satisfies this property. And what about the right hand side? Right hand side में at most अगर रहा तो ज़्यादा से ज़्यादा, here नहीं रहा तो भी चलेगा. That here non-terminal symbols यहाँ पे present नहीं है. This A is what? It is denoted in small letter. That means what? It is my terminal symbols. So one terminal symbols can be present on the right hand side of the production rules. So this is what? This is my valid regular grammar. If I write it down, my production rule is like this. A produces small a, capital A. This is what? Left hand side में exactly one non-terminal है. It satisfies this property. But what about the right hand side? Right hand side में at most one non-terminal symbols. Yes, one non-terminal symbols है. एक से ज़्यादा तो नहीं है. Only one is there. Only one. At most one non-terminal symbol is allowed here on the right hand side of the production rules. So I can say that this is again my valid production of regular grammar. If I am having a regular grammar like this, B produces this A, B. This is what? This is again, it is accepted. Why it is accepted? Left hand side में एक है. राइट हैंड साइड में भी एक है. एग्जैक्टली दिस ऑलमोस्ट एट मोस्ट एक ही है. फॉलोड बाय उन्होंने they have not put any restriction on the terminal symbols, right? Any number of terminal symbols can be present on the right hand side of the production rules, right? But राइट हैंड साइड में नॉन टर्मिनल सिंबल्स रहेगा तो कितना रहना चाहिए, एटमोस्ट एक, राइट। लेफ्ट हैंड साइड में एक ही रहेगा, उसके साथ कोई भी सिंबल्स नहीं चलेगा, कोई भी टर्मिनल सिंबल्स विल नॉट बी प्रेजेंट ऑन द लेफ्ट हैंड साइड। लेफ्ट हैंड साइड में एट मोस्ट द लेंथ ऑफ माय लेफ्ट हैंड साइड ऑफ द प्रोडक्शन रूल्स ऑफ रेगुलर ग्रामर विल बी एग्जैक्टली 1 एंड दैट हैज टू बी अ वेरिएबल. But on the right hand side of production rules, any number of terminal symbols can be present. But what it says that it put the restriction on the non-terminal symbols. Non-terminal symbols at most रहेगा तो एक ही रहना चाहिए. So that belongs to what? My regular grammar. I can say that this is what B produces AAB. Here, what it says कि लेफ्ट हैंड साइड में एग्जैक्टली वन नॉन टर्मिनल सिंबल है, दैट इज अलाउड. बट व्हाट अबाउट द राइट हैंड साइड, एटमोस्ट वन नॉन टर्मिनल सिंबल है. Yes, this capital A is there. That means what? This is again, it satisfies this property. But what it says that I can say this is not my regular grammar. Why it is not my regular grammar? Because the position of non-terminal symbol does matter here in the regular grammar. Position of non-terminal symbols कहाँ है? दो terminal symbols के बीच में है. This is not allowed in the regular grammar. So I can say that this is not my regular grammar. So we'll discuss it further. This regular grammar is further divided into two parts, left linear grammar and the right linear grammar. As we have discussed here, even though this follow this both the property, left hand side and the right hand side, left hand side में exactly एक है, right hand side में at most एक है. Even though I can say that this is not my regular grammar or this particular production rules are not belongs to regular grammar. Why it is so? So here we'll say that कि इसका position जो है ना, this non-terminal symbol का position does matter here. Why? Because what it says that this non-terminal symbols cannot become in between, right? If the non-terminal symbol is present on the right-hand side of my production rule, then उसका position it should be either the leftmost symbol or either it is the rightmost symbol. So we'll see that based on this position of the variables that are present on the right hand side of the production rules, based on that regular grammar is further divided into these two subtypes called as a left linear regular grammar and right linear regular grammar. तो हम किसे left linear बोलेंगे और किसे right linear बोलेंगे. For example, if I say that A produces capital B and small a, what it says that again it is same thing. Left hand side में exactly one है, right hand side में at most one non-terminal है. But here what it says that what is the position of my this B? What it says that this B is present on the right hand side of the production rules. But what about this the position? इसके पहले कुछ है, किसी के बीच में आया है? नहीं. It is present and it is the position of this B is what? It is a leftmost symbol that are present on the right hand side. मतलब right hand side का leftmost symbol जो है वो मेरा non-terminal symbol है. That is why this particular grammar is called as a left linear grammar. Why it is left linear? Again I'll repeat. Why it is left linear? Right hand side में at most एक non-terminal symbol है, that is allowed. But उसकी position कहाँ है? The position of this B, that is what? That is my non-terminal symbol is the leftmost symbol that are present on the right hand side. That is why it is called as left linear regular grammar. Right? Here I can say that this is allowed here. नहीं रहा तो चलेगा, रहा तो मैक्सिमम एक ही नॉन टर्मिनल सिंबल रहेगा जो कि राइट हैंड साइड में है. यहाँ पे राइट हैंड साइड में zero non-terminal symbols are present. Even though I can say that this is my valid production of regular grammar, I can say that this is my left linear grammar. A produces epsilon. Again, what it says that right hand side में only thing is that we need to consider at most one non-terminal symbol has to be there. उसके बदले में कितने भी मेरे terminal symbols can be present on the right hand side of the production rules of regular grammar. So all these three rules, all these three production rules are my valid production rules and they are called as a left linear regular grammar. Right. So what is the difference between left linear regular grammar and the right linear regular grammar here? So here you can say that if A produces small a and B, what is the difference between this here? I have swapped the position of this B from here to here. Right. So here we'll come to know that A produces or A derives small a B. Again, left hand side में कितना है? Only one. And that is says that exactly one non-terminal symbol has to be present on the left hand side of the production rule. that is accepted. What about the right hand side? Right hand side में yes definitely one non-terminal symbol is present. एक ही non-terminal symbol है, exact at most रहा तो at most एक ही रहना चाहिए. It also satisfies this property. But what is the position of this B? B is present on the right hand side of the production rule, and the position of B is a rightmost symbol, right? So that is why it is called as a right linear regular grammar, right? So here I can say that can be like this: A produces small a or A produces epsilon. It means what? The regular grammar says that left hand side में एक, right hand side में रहा तो maximum एक, but the position of that non-terminal symbol has to be fixed. Either if it is present on the right hand side of the production rules, if the position of that non-terminal symbol is a leftmost symbol that has to be present on the right hand side, then I can say that it is what? It is my left linear regular grammar. या फिर if the position of my non-terminal symbol that are present on the right hand side of the production rule and that non-terminal symbol का position is the rightmost symbol, then I can say that this production rule belongs to right linear regular grammar. उसके बाद any number of terminal symbols right hand side में any number of terminal symbols can be present, but the position of this B does matter here. The position of this B or the position of a variable or a non-terminal symbols can be either leftmost symbol or rightmost symbol. So this is my regular grammar here. So what we have seen, the type 3 grammar generates what? What is the type 3 grammar? Type 3 grammar is my regular grammar, and regular grammar generates a language called as a regular language, and we are having an acceptor called as finite automata. So finite automata is a mathematical tool or mathematical machine which will accept the language generated by regular grammar. Thank you.